Problem number 13a. In the figure 1, this is that figure given below. Qx and Rx are bisector. Qx and Rx are bisector. Qx means this is Qx and Rx are bisector of the angle PQ, means this angle, and PRQ, this angle, respectively, of triangle PQR. If XS is perpendicular to QR and XT is perpendicular to PQ, prove that number 1, triangle XTQ, means this triangle XTQ is congruent to triangle XSQ, and number 2 is PX bisect the angle P. Okay, so we have to prove it. At first I will write what is given here. So solution given Qx is bisector of angle PQR, okay, and Rx is bisector of angle PRQ, okay, and XS perpendicular to QR and XT perpendicular to PQ. All these conditions are given here. We have to prove number 1, triangle XTQ congruent to triangle XSQ, and number 2, PX bisects angle P. For that purpose I will make a construction. And what is the construction? I draw a perpendicular from X upon PR and name it as XZ. Therefore construction, what is construction? XZ perpendicular upon PR. Okay, now proof. Number 1, we have to prove XTQ congruent to triangle XSQ. So here we take in triangle XTQ and triangle XSQ, angle XTQ is equal to angle XSQ, both 90 degree. Next, angle TQX is equal to XQX, because here you can see QX is the bisector of angle PQR. QX is the bisector, therefore it divides the angle PQR into equal parts. So obviously TQX is equal to SQX, since QX is bisector of angle PQR. Okay, therefore these two angles are equal. And last one is QX is equal to QX. This is common side between these two triangles. So here you can see which criteria we can put here. Angle is equal to angle, suppose, therefore it will be angle is equal to, and next one angle is equal to angle, and last one is side is equal to side. So therefore triangle XTQ is congruent to triangle XSQ by which law? By AAS congruence rule. Okay, so number 1 is proved. So this is proved. Now we will prove number 2, that is PX bisect the angle P. So here we can write XT is equal to XS by CPCT rule. Okay, and I put it number 1. Similarly, from triangle XSR and triangle XZR, we can prove XS is equal to XZ. XS is equal to XZ. We put it number 2. Now from number 1 and 2, from 1 and 2, what we get? Xt is equal to xs and xs is equal to xz. Therefore, xt is equal to xz. Xt is equal to xz. Therefore, we get xt is equal to xz. Xt is equal to xz from 1 and 2. Now, in triangle XTP and triangle XZP, this is Z. XTP and XZP, we can see here angle XTP is equal to angle XZP is equal to 90 degrees. Since both are perpendicular, XT and XZ are perpendicular upon PQ and PR, therefore both are 90 degree. Okay, and here you see XP is hypotenuse and this is common to both, and XP is equal to XP, common in both the two triangles. And last we proved XT is equal to XZ. This is already proved. So in these two right angle triangle, hypotenuse are same and another side is also equal. So these two triangle is congruent. Triangle XZP by which rule? By RHS rule. Therefore these two triangles are congruent, therefore their corresponding part will be equal. So we can write XPT is equal to angle XPZ by CPCT rule. Therefore these two angles are equal, therefore obviously PX is bisector of angle P. Therefore PX is bisector of angle P. So this is proved. Okay, now we will solve problem number 13b, and the problem is in the figure 2. This is the figure 2 given below. AB parallel to DC. AB parallel to DC. Prove that AD is equal to BC. AD is equal to BC and AC is equal to BD. We have to prove these 2 points. Okay, so here given AB parallel to DC and angle C is equal to angle D, we have to prove number 1 AD is equal to BC and number 2 AC is equal to BD. For that purpose I make a construction. So construction, here I draw a perpendicular from A upon DC, that is called AE, and another from B upon DC, this is called F. Okay, This is called F. So the construction is draw AE perpendicular upon DC and BF perpendicular upon DC. Now proof. In triangle ADE means triangle ADE means this triangle, and triangle BCF angle D is equal to angle C. This is given condition, so I write it here given. Next one is angle AED is equal to angle DFC. Why? Because these two are right angle, both are 90 degree. And next AD is equal to BF. Why? Because distance between two parallel lines are always same. These two lines are parallel, it is given. So this is the distance between these two parallel line is always same. So these two are equal. So here we write distance between AB and DC are same, because here AB and DC are parallel. Therefore, we can write triangle ADE is congruent to BCF, by which rule? Angle side by AAS congruence rule. Okay, so therefore we can write AD is equal to BC, by which law? By CPCT rule. Okay, so number 1 is proved. So this is proved. Now we will prove number 2. For that purpose, we will draw another picture. A, B, C, D. Here D is equal to C. This is given. In that case, we will make another construction. Here we join B and D, A and C. Okay, so here construction is join AC and BD. Okay, now proof. In triangle ADC and triangle BDC AD is equal to BC. Already proved. Okay, and angle C from angle ACD is equal to angle D from a triangle ABDC. This is given. Okay, and DC is equal to DC. This is common. Okay, common side between these two triangles. Therefore, these two triangles are congruent. Therefore, we can say ADC congruent to triangle BDC. By which law? By SAS. SAS. Sides are same, equal, angles are equal, then sides are equal. By SAS rule. Therefore, we can write AC is equal to BD by CPCT rule. Okay, so This is also proved.